Salams and salam sejahtera and good days, ladies and gentlemen. I hope all of you are doing well this morning. Thank you for joining IEMSS UTHM Solidworks Workshop. I am Angelica Tijan from IEMSS UTHM and I will be your host for today's event. As we are about to begin, I hope all of the participants will switch on the camera for better interaction with our speaker today. Next, I would like to remind the participants to make sure that your microphone is muted to minimize distraction from audio feedback. Last but not least, please click on the raise hand button and turn on your microphones once allowed by the speaker if you have any questions or concerns during the session. Before we continue for our event today, I would like to introduce our speaker, Professor Madya IR Dr. Chee Kiong. He is a professional engineer who graduated with PhD in engineering at Nagoya Institute of Technology, Japan. He is one of our panel leaders for Faculty of Mechanical and Manufacturing Engineering, Department of Material Engineering Design, JKVR, as well as a focus group leader of Faculty of Mechanical and Manufacturing Engineering, Engineering Design Research Group, EDRG. IR Dr. Chee Kiong is also a member of Institution of Engineering Malaysia. He is an Autodesk Certified Professional, which is in AutoCAD, Certified SolidWorks Professional in Mechanical Design, and Certified Professional SolidWorks Advanced in Drawing Tools, Sheet Metal Weldment, and Surfacing. His research and grant contracts include the development of mold to produce composite hollow product using ladder-assisted composite manufacturing method, as well as an improved convolutional neural network on two-way monitoring in the machining process based on the image of machine surface texture. He has also contributed to the new optimization algorithm for mechanical engineering problems, the portable electrical categorization system for soil, and lastly, an electromagnetic shielding effectiveness of plaster cement mixed with graphene PUFA for mitigation against electromagnetic interference. With a very impressive background, it is an honor to have the presence of IR Dr. Chee Kiong to be with all of us today. I believe that we are in for a treat today. Now, without further ado, please welcome our honorable speaker, Professor Madya IR Dr. Chee Kiong. Professor, the stage is yours.
All right, thank you, Angelica. Thank you. Okay, so quite a number of introductions. Okay, so before I proceed with our workshop today, I think I just distribute the link for you to download the module. We will use that module for our workshop today. Okay, try to share my screen. At the meantime, before we proceed with our workshop, I would like to let you know UTHM, okay, is among the certified academics certification provider for SolidWorks. Okay. Means you need to complete all the necessary trainings hour in order for you to sit for the exam and get certified from the Dassault system, which is the SolidWorks. And our certification valid until August 31st this year, and we will keep renewing it since we are qualified to get this certification provider. So before I proceed, I would like to know how many of you ready with SolidWorks here? Because I forgot about the SolidWorks. If you are ready with SolidWorks, can you raise up your hand? I want to see. None of you. Okay, none of you. It's okay. None of you. So if you let me know early, maybe I can provide you the student kit, the student kit software, which is the original license from UTHM. But it's okay. But it's okay because I try to introduce. So this is 3 hours workshop, and I have think over what should I share. Okay, because for the product design, we need at least 6 days to complete the course. Then after I consider the different fields between us, then I come up with this idea, which is I try to introduce the Solidworks element and structural system. Okay, so this structural system we can use in mechanical, can use in civil, even in electrical for maybe conveyor design and so on. Okay, and the weldments mean this part. This is the platform. This is among my project. Okay, I involve a lot of project, consultants project outside. Okay, this is among my project. Okay, so you can see this is the product that can use Solidworks to create from. So as an introduction, okay, what is Solidworks weldment? The weldment's functionality enable you to design a weldment structure. We will use this simple example today. Okay, this simple example today. Okay, structure as single multiple part means you can create a single part and multiple part. Okay, and the structure system is an advanced weldment environment that let you create and modify structural member of different profile in one features. Okay, I will explain what is profile and what is features later. Okay. So this is the project I mentioned just now. Okay. And instead of designing some things, we can come up with cut list. Okay. I think this is very important for the procurement engineer. Okay, to list up or stock up all the necessary raw material for the projects. Okay, raw material maybe for the shipment, early shipment before the project begin. So if you use this method step by step, I believe after you install your own SolidWorks, you can at least can create something simple. Okay, so try to compact it down like this. Okay? So actually for the weldment step by step here, okay, we will focus on this, which is I circle with this red circle. Okay, focus at this 5 step. Okay, for the weldment, can create the cut list, which I mentioned earlier, this cut list. And then we can estimate the weight of our products. Okay, since we assign the material, for each product, then which is the properties of the material, example the density of the material and the volume of material. Then we can come up with the overall weight estimation. And then the third one is the analysis validations. Before we draw or turn our design into the 3D model, of course we need to design and analyze. We need to select size or the profile of the structure. Okay? And then for this SolidWorks, we can validate our design. Either it's safe, can be used in public or not. Okay. And then for the marketing purposes, this SolidWorks can render the products into our 3D model into photo looks product for the visualized purpose. It looks real. Okay. You can assign any types of material or appearance into the material. Okay. Even you can write down your names or put your photo on the structure. Okay. And the last one, I think this is the most important. This one I will not share with you today because it's quite a long time necessary which we need to create a detailed drawings. Okay. detailed drawing is the way how engineer communicate with each other. Okay? If you are able to create a detailed drawings and you can share it to any engineer around the world, but the drawing that you created using the available standards, I think should be no problem lah for the other engineer to understand what you are focusing about. Okay, so we will go through one by one lah, okay, one by one, step by step. Okay, so if you have any questions, you can ask. Yeah, you can type down, or maybe you can raise up your hand, and I can try to answer your questions, okay, about this SolidWorks. Okay, before we start with our workshop today. No? Okay. No. Okay. So for our workshop today, we start with the design lah. This is the simple design lah. I created for this workshop, for the purpose of this workshop lah. Okay. What is this? This is the class lah. From the steel, and the shapes or the dimensions for this structure is look like this. Okay, which is the length is 1 meter or 1000 millimeter, and the maximum height for this structure is 300 millimeter. And then for each line here represents the 1 × 5 inch rectangular tubes. Okay, I purposely do it like this, combine between the millimeter and the inch units, because you will facing it during your involvement in the industry lah. In Malaysia, we are not focused in any, we are not stick with any standard. We use variety of standard lah. Okay, we use inch, sometimes we use inch, sometimes we use SI. Okay? So we try to get used with Malaysian culture lah, which is to try to mix up two units together. Okay. So of course we need to start with the sketch, okay, because this is the sketch after I design. Then I will proceed with the sketch. Okay. This is the sketch. Okay. Then this is the design. Let's say this is design after I do the analysis, which is what we have learned before during your engineering course. Okay. And you come up with this design example. You calculate all the moments, all the shear force and everything, and you consider, after you do the analysis and you consider this safe, then you can come up with sketch using the SolidWorks. Okay, so for those who first time involved in SolidWorks, this is the environment of SolidWorks. This is the environment of SolidWorks. Okay. Okay. So what can SolidWorks do? What can SolidWorks do? Okay. So this is the environment that if I want to open the new file of SolidWorks, okay, start here lah. Let's click at it's new as usual. When I open the file, there are 3 types of file available. Okay. The first one is the part file. The second one is the assembly file, and the third one is the drawing file. For the part file, we create a single part lah. The single part. Okay. For example, if you got a bottle flask beside you, okay, the cap is one of the part, and the body of the bottle is one of the part. And to combine the cap and the body of the bottle, we will use the assembly file. With the assembly file, and this is the single part, and this is combination of one part. And then the next one is the drawing. Okay, this is we turn all we design in 3-dimensional into a 2-dimensional or a piece of paper. Okay, and we can print out in any format. Any format. You can shape the engineer all around the world. Okay. Okay, I'll show you how to start lah. Okay, so to start, this is the environment of SolidWorks. This is the interface. And in my module here, I show you step by step lah. So maybe you can try to get the SolidWorks so-called educational version. Okay, try to install it and you just follow the step here. I stated the step clearly lah. Even which key should you click? Should you click? Okay. Which key should you click? Okay. So until now, we open the new file lah. Okay. Take time to load. Okay. All right. Okay. This is the environment of it. Then we will start to sketch. Okay, we will sketch this profile, this line lah. This line lah. We start to create this line lah. This line over here like this. Okay. So before we start with our sketch, I would like to let you know lah. We only can sketch at the flat surface. The flat surface. The flat surface means either plan available here. You can sketch from the front plan. It's a flat surface because this plan located parallel to X and Y axis. Oops. Between X and Z axis, and for the right is X and Y axis like this. So we will sketch this according to this dimension over here. Okay. So let's say if I want to start from the right plan, quite simple lah. You just right click at any plan that you want. Let's say I want to write sketch on the right plan here. I just right click. Okay. When you right click, there are two small windows will pop up like that. Okay. Smaller ones and the bigger one. Ignore the bigger one. We focus on smaller one here. Okay. There are 4 toolbar available there. Over 4 toolbar. If you not understand what toolbar is it, you can move your cursor to each toolbar. Okay. You can move your cursor to each toolbar. And there are explanations about the toolbar. Okay. For example, I move it to here, means show. First one is sketch. So we select sketch because we want to sketch on the right plan. Okay. So when I click sketch, then just now the orientations of our view in isometric view. Okay. After I start our sketch, then right plan will normal to our screen lah. Turn normal in our screen to make us easier to sketch. Okay. Make us easier to sketch. Okay. But before we begin, I would like to let you know lah. At the center here, there are an arrow. And between the intersections of the arrow, there are point. Okay. This point represents the origins. Origins means it's a global coordinates, 0 in X, 0 in Y, and 0 in Z. Okay, so this means it's the intersections of 3 different plans. This is the front plan, top plan, and right plan. The intersection point is at this origin. So every time when you start with any sketch, I recommend you to start from origin. Doesn't matter which side you want to start. Why I say like that? You can see, for example, if I create a circle, okay, then I still can move my circle anywhere I want. I hold it and I can move it any way I want. But let's say if I move my circle and my circle, center of the circle located coincidentally on this vertex, means my circle is stay there, like, cannot be moved, but we only can change the size of it. Okay. So that's why every time you start your sketch, it's better for you to start from origin. Okay, so we start this one. We sketch this one. To sketch this one is quite simple. The method is very simple. Very simple. Okay. Just, you know, this is a straight line, because I sketch it out using freehand. Like curve. This is command for the line. This is command for the line. When I click this toolbar, but before I start, you can see the shape of my cursor. This is a normal cursor, white color, normal cursor. But when I activate this command, means the line command, you can see the difference. My cursor turned into a pencil, and just below the pencil there are straight line, means ready to sketch a straight line. We start it from the origin, and second click, third click, and cross the sketch. Okay, like this. So very simple, very simple, very simple. After we finish with this geometry, this is the outside of our area. We can proceed with the inner line here, inner line. Please sketch it like this. Remember, just create the overall shape first. Overall shape. It's so different, because there are dimensionless. We haven't put any dimension yet. Yeah, after we set the dimensions, then you can realize the real looks of our design. Okay, so until now we complete our geometry . This is actually the part for the awning . For the awning, this one. This one. After I finish with the geometry, status of my sketch is still underdefined. Okay? Underdefined in SolidWorks means we still can move it, and we still can change the size or the shape. For example, when I hold this endpoint and I drag it, the shape still can change. The reason it can change because we lack of something here. Known as dimensions. Okay? We need to insert the dimension in order to make sure the status of our sketch is fully defined. Now it's still underdefined. So we will insert the dimensions for each line to make sure this sketch of the underdefined turn into the fully defined status . For the dimensions, this is the command for the smart dimension. Okay? It's different compared to AutoCAD . For AutoCAD, for the circle, they have their own toolbar for the dimensions. For the radius, you got the on toolbar for the radius, for the angle, and so on. But SolidWorks is different. For the SolidWorks, you can use only one toolbar to complete everything. Okay? I start by dimensions. I will show it to you, then you will understand what I mean. Okay? So we start with this smart dimensions. As I click here, then I just click at the bottom. Not the bottom. I click on the line. Okay? The line is 1000 millimeter. 1000 millimeter. I just click on the line like this. Okay. Then I just change the value into our value lah, which is 1000. Then we can click OK. It's simple as like that. So currently, the length for this bottom line is 1000 millimeter, which is what we want lah. What we want. Then the rules is simple lah. The rules is simple. Every time when you insert the dimensions, I recommend you to insert the highest value. Okay. For this case, the highest value is 1000. So I pick 1000. Okay. Of course, it's not written in any books, but this is based on my experience lah. Okay. Otherwise, the shape will change. Then the next one is 300. Side. 300 this side. Very simple. We just change the value like that. And for this side is 100. So click on the side. It's 100. Okay. How about the inside? How about the inside? Okay. Just now, I picked the line. Means I measure the entire length of this line. Okay. How about the distance between this point, this point? We can do it easily. We can select the point that we want to measure. Let's say I want to measure here. And I click at another point that I want to measure. Okay. Like this. Okay. So this is how we do the dimensionings on this part lah. And the dimension is 320. Just we change the value to 320 millimeter. Like this. Then we try to complete the sketch. Try to complete the dimensions. This point to this point is 320. So when everything is ready, try to rearrange the dimensions. Okay, it's very important lah, because people know your works is tidy or not lah. Try to arrange. You can move the dimension anywhere you want actually. You can move it like here or where lah. So try to arrange it like this. Okay. So for this structure, the overall frames was completed lah. Okay. Just now, the status of our sketch is underdefined. Now it's fully defined. Okay. When the status of my sketch is fully defined, it means I cannot move my part and I cannot simply change the shape anymore, because it already covered up by this dimension lah. Okay. Dimension. So after I complete with these dimensions, okay, then I will call out the Wellman tab. What is the Wellman tab? Okay, let's say I cross this Wellman tab. I cross this Wellman tab. Not all the tabs is available. Not all the tab is available. Okay. So this is the tab that available here. Start with the features. This is we call tab the tab. And this is the toolbar. For each tab, got different toolbar. For each tab, got different toolbar. Okay. For the Solidworks. Okay. Now we will play around with the Wellman tab, the Wellman situation. So show you how to call or add in the toolbar for the tab for the Wellmans. Just select any tab here, any tab, and right click on it. Just right click on it. And go to the tabs here and just check on any tabs that you want. So now we will run Wellman. Check on the left side of this Wellman here. Then the Wellman will Here, this is for the Wellman. So when I click on the Wellman, this is the home toolbar for the Wellman. Okay. So this Wellman is come from the worldwide standard. You can use this standard in our design today. Okay, in this Wellman, okay. The standard that available is ANSI from the American National Standard Institute. And this British standard, I think in Malaysia, most of the civil engineer in Malaysia use this standard. But CISC is a court standard practice of structural steel. This is from also from the US. German Institute standard or DIN. Even the Chinese standard also available in this SolidWorks. Okay. Call it Go-Bio standard or GB like this. Not all, also like you got ISO and Japan industrial standard. Okay. If you ask me which standard I prefer NC standard because this standard quite established. NC standard. So how to select the standard I want to use here? Okay, turn back into the SolidWorks. Okay, I forgot to mention about the unit The unit. Currently we are using millimeter. How I know this is the millimeter? Look at the bottom right on the screen here. Here are units: millimeter, grams, and second. Okay, you can change the unit as well. Expand it, and you can change any unit you want. For the bigger products, maybe we can bigger product with less accuracy. We can use meter, kilograms, second. But medium accuracy, we can use millimeter, centimeter, gram, and second. For the high accuracy, you can use millimeter. Even you can control the number of decimal place. But for my SolidWorks, I purposely do it at 2 decimal place. Means product that I design is accuracy product. So back into our standard here. Instead of this standard, this is the file of this standard here. See, we got C channel. Check how the C channel look like. And this is the S sections. Have iron, rectangular tubes, and square tube like this. And it's available in a lot, many dimensions. Okay. So for the civil engineer, maybe you need to determine the seconds, moment, area, initial for each structure here. But don't worry because SolidWorks already calculate it for you. This one. For the electrical engineer, don't worry because you can customize your own profile. Okay? Maybe you want to create a 3D printer using 3D printer. Okay? You can create your own structure, your own profile. Okay? You can create your own profile like this. Or maybe if you want to create the rail for your movement of your motor, and create on your own. Customize your own profile. It's very common for you to create your own profile. Not only the shape. This shape I purposely create like this because I don't want to take the shape of others. Maybe got the issue of copyright issue Then I create my own part. Okay. So this is the step how we customize our profile. I will not go through this. Okay, I can simply go through for this profile. So I just leave it this one profile. But if you follow this step, you can create your own profile. So continue from that, we still use our example. Then the next one is we will select the structural member in our design just now. Our design, we will design this part, which is created from the 1 inch times 0.5 inch rectangular tubes. Okay, so we will use this profile for this structure. Okay, so we follow the step. Okay, so we go to the Wellman tabs. This is the Wellman tabs. But before I can make sure this command is active, I need to cross out. To cross out this sketch first click this button here. Okay. When I click this button, then the command in this structural member will turn into active command. Okay. We start with the structural member. This is the structural member. Okay. And this is the properties manager for this structural member. Okay. This is the properties manager for this structural member. Start with NC. This is the standard that I mentioned just now. Okay. Start with NC. And the types is I'll use tube, rectangular tube. And the size is 1 inch times 0.5 inch. 1 inch and 0.5 inch. So rectangular. Okay. Times 0.064. This is the thickness of the wall. This is. So it's very easy. It's very easy to create structure. Even this is first time you join, maybe this is first time you expose with SolidWorks, then you can use this method. Very simple. Okay. So after I select the desired profile, then I just click the outside or the outer line here. Okay. Click line. Okay. This line. This line. And this line. Then the line here will turn into the profile that we sketch, that we select just now, which is the rectangular tubes with the dimension of 1 inch times 0.5 inch. And the thickness of this wall is 0.064. So you can see how it looks like. It's very simple. Okay. After we complete, then we need to create the second groups. The second group, then we can need to create the new group. The new group. The new groups. And we use the same profile. And we continue to create the rest of the line here. Okay. Bear in mind, when you select the line, you must select it in sequence. And we cannot select this one and then jump into this one. Because when I click on it, the profile will not appear here. You need to continue in sequence from here. And since the line is joined here, then you can click this line. Then the profile will show up. Then select any line that join this profile. Select this line. And I will try to complete the selections like this. Okay, complete the selection like this. Okay. When everything is ready, then I can click OK here or OK over here. Okay. So this is our overall structure. Okay. Even we can view it cross-section view. I mean, I can see how the inner part look like using this section view. Section view. Yeah. To move it, you can see how the inner part look like. Yeah. It's very detailed. It's very detailed. Okay. Maybe I want to see the intersection between these three points. It's look like this. Okay. Simple. Okay. Pull it. Yeah. Okay. So, but okay. But when we create or we turn into the production process, okay, then we consider about the material and the production process. Okay? For example, when you cut the corner here, look like this, maybe it's difficult compared to this line like this. And you can pick any treatment that you want, any type of shapes that you want, like this, okay? Like this, or like this, or like this. If you ask me, I will prefer the second one. Maybe this structure will have a better strength. This is my opinion. This is my opinion. If like this, there are open is the hole is open, it's exposed. But for this one, it's still open, but in the side way. This one, everything is closed. If there are water go inside, then there are no way for the water to go out. So I prefer this one. Or how we treat this corner? How we treat this corner? This is our structure. Okay. I want to change the top here. This corner look like this. Corner look like this. What I need to do, I just need to edit structure. The command is simple. Just right click, either right click or left click only in Solidworks. But you need to select the correct command. Okay. So this is the rectangular cube. I just click on it and I edit it. And I edit it. So there are dotted 1, 2, 3, 4, 5, 6, 7. Add dotted. Okay. Each dotted represents the join between each structure. Okay. Each dot here, this purple dot here means it join between this structure to this structure. Okay. And for this dot represents the join between this dot, this structure, even this structure as well. Three structure join into one point like this. Okay. So how can I change it? I just simply click at this dot or any location that you want to change. Want to change this dot like this, just click on the dot and you can select the shapes of corner that you want. Yeah. For example, if I click the first one, then it will change like this. The third one here, it will turn like this. It's very simple. Very simple. So I want like this. I want it look like this. Then you can click OK. Then now, how about this one? This one is okay, but if I want to change it, I can. For example, I want to focus on this diagonal directions, which is this structure where we have come to here. Just change the trim order. Okay. It will look like this. Excuse me. Okay. I think for this corner is okay. Like this. The last one, pick it and change it until it's look like this. Okay. So if the corner is look like this, means it's easier for us to produce lah or cut the structure. The structure easy to be produced and easy to be well as well. Okay. After everything is ready, they can click OK here. Oh, okay here. This is our structure. It's complete with any which is the corner that we want lah. Corner that we want. Maybe we can change here. Here, I am not happy with this joint. So click here. Then I can order like this. Okay, click here. Yeah, like this is better. Like this is better. See? Better. Okay. This corner. Okay, this corner is nice. Corner, it's not good. Change again. This. You can change each corner. But it's okay. And this one is okay. Okay. When everything is ready, they can click OK. And our design looks nice. Okay. So the next step is our structure is complete. Now our structure is complete. And of course, for this structure, we need to add in additional pad behind it. Okay? Because we need to fasten this structure on the wall, on the concrete wall. Okay? We need to add in additional pad. Okay? So now we are not using this structural member or weldment approach. We will use common Solidworks 3D method to create the plat. Okay. I will create the plat with the dimension of 50 millimeter times 50 millimeter, and the thickness of the plat is let's say 5 millimeter. Okay, 5 millimeter. So for your information, for the Solidworks, we can sketch anything, but as I mentioned earlier, we need to sketch it on the flat surface, on the plan. Even we can sketch it on this surface, on this face. Let's say if I want to sketch some things on this sketch, I just click on this face and select the sketch toolbar. Okay. This is the sketch toolbar like this. If I want to sketch here, then I click. Then you can sketch at this surface. Even we can sketch inside as well, everywhere, as long as the surface is flat. Okay. So I'll try to sketch here. Sketch here. When I sketch, then you can see the surface will hover to the screen to make us easier to sketch. Okay. Now the next step is simple. I will use corner rectangle. Just now our sketch tool is line, but now I will be using corner rectangle. For the rectangle, when you expand this command, there are variety of command for the rectangle. But I will use corner rectangle. Okay. Corner rectangle. And you can see the cursor look like pencil and the corner and the icon of corner rectangle at this cursor. So I will sketch exactly on the edge of this surface. Okay? So the SolidWorks provide you the feedback lah, when you move near any entities like surface, like edge, or any vertex, it will auto relate it to you. Okay, so let's say I want to sketch it here, fine. Click it, and then I drag it. This. Okay. So after I create the the geometry, then I need to insert the dimensions. If not, our status keep underdefined. Or as I mentioned, the size is 50 by 50. To complete, I will try to sketch it at the top and the bottoms like this. Okay. Oh yeah, before I forget how I control this this view, I just scroll my mouse lah. Scroll the mouse up and down, so it will provide the magnifications. Okay. Okay. Like this. Okay. Then I will insert the dimensions for each side. This is the command for the smart dimensions. 50 and 50. And 50. And we try to complete for the both rectangle. 50 and 50. Okay, so we are complete now. We are fine because status of our sketch now is fully defined. Okay. Proceed. But before I proceed, of course, I need to create the hole for the fastener. Not for the fastener, for the wall plug. Okay, the wall plug. And I draw a circle inside this rectangle for the both rectangle. And the size of the wall plug normally in a round number lah, like 10 millimeter in diameter, 12 diameter. So we try to give the dimension of the hole, let's say 10 millimeter. 10 millimeter. This is the size of the circle. Okay. This is the size of the circle. And if I want to locate the circle, I can use the dimension as well. Okay. Now, instead of sizing the circle, I can use the dimensions to locate our circle as well. Currently, our status is underdefined because we still can move our circle anywhere we want. Of course, it's stick with 10 millimeter. It's movable. So we need to keep our circle stick and locate at the center of this rectangle using dimensions. Okay. So if I want to locate our circle at the center of this rectangle, then it means this center should be located 25 millimeter, which is half of this dimension lah. 25 millimeter from this edge. So I'll use these dimensions to measure from this side to the center. Like this. And change the value to 25 millimeter. And from the top to the center in this direction as well. Okay, so just now, color of the circle is blue and turned into black after all the dimension is complete. Still underdefined because we need to complete for another circle. Okay. We'll do the same process. The edge at the center, like this, 35 millimeter. And to the top, to the center, like this, also 25 millimeter. So when everything is ready, then you can see complete with all the dimensions. For the reminder, you need to rearrange all the dimensions properly. Okay, so ready lah. Try to avoid any intersections between the dimensions. Like this is not recommended. It's not recommended. It's quite confusing. You try to make sure the shorter dimensions located inside. Meanwhile, for the longer dimensions, you put it outside like this. It's 10 millimeter. Maybe here. Nice. Okay. For this bottom one as well. Okay. Fine. This 10 millimeter, I can change the leader. This. Okay. So everything is complete. Our status for this sketch is fully defined. Fully defined. But when I change the view, it's only a sketch, means there are no thickness at all. It's only a line lah for both circle, or for both geometry like this. It's only a line. Okay? So we need to give a thickness for our sketch, okay? Which is represents the plate that we want to create. Okay? So to do that, we need to select the features. For the feature step, normally is used to create and edit the solid. Create and edit the solid. So we try to give a thickness. For the thickness, can try to understand the shapes of the toolbar here. Okay? When you move it, there are explanations. You can see the explanation. Even it shows how to use this toolbar. Okay. For the remove, there are explanation over there. The usage of this command. Okay. Very user-friendly actually, this software. Okay. Okay, so we start with extrude. We use extrude. When I click extrude, you see the thickness for both sketch will appear. Okay. And what is the value of this thickness? Our M is 5 millimeter, but currently by default is 10 millimeter. So I need to change the value that we want. 5 millimeter. 5 millimeter. Okay. So now the thickness of our plate is 5 millimeter. Okay. But the directions, you can see properly, if I turn it look like this, the directions of the extrusion is opposite. Okay. We want the directions of the pull to the left, but now it's currently to the right. So what should we do? We just need to change the directions. I click this button. You need to reverse the directions. Okay. It's very simple. When you click on these directions, it's automatically turned into opposite direction like this. Okay. Okay. When you are ready, check again. Our condition is fully defined. You can click OK. This is the plate that we sketch. It's complete. It's complete. Okay. It's complete. Okay. Then for the next step, okay, I'll show you how to change the view into the standard view. Okay. Here are 3 methods that are available. The first method, you can use a keyboard. The second method is you can use the command, and the third one is combination between the command and the keyboard. Okay, So we use the combination lah. Hit the spacebar key on your keyboard. Then this toolbar will show up lah. And this is the orientation that we can select. The view that we can select lah. This is the top view, front view, bottom view, and so on. This is the isometric view. So like this. Or you can use the command right here. Okay. Also the same. You can select it. Okay. You can select it. Any view that you want. Okay. Or you can use the shortcut key. Control 6, Control 7, Control 8, and so on. You can select. Okay. You can customize your own view lah. Okay. I will not show you today how to do it. Okay. This is the view. Okay. But when you scroll it, for example, when I locate my cursor here, when I scroll it, it will move there. But when I locate my cursor here, I scroll it, it will move there. So if you get used with this mechanics, then you will be able to create the drawings in easily create very fast. Okay. When it's ready, we complete. Proceed with our next command, which is for information. Currently, the material we not yet assign any material for this structure. So try to assign the material, which is the steel in steel. I prefer to use this AISI 304 material. AISI 304 material. Okay. To assign the material, you just need to go to Features Manager Design Tree, and this is the material. Right click on this material and edit the material. Edit the material. So this is the material available in the database of SolidWorks. We have the steel, irons, aluminium, copper, titanium, and so on. Okay. For the steel, we know the steel is combination between iron and carbon. Okay. Iron and carbon. So we use this steel, and we use this AISI 304, this material. When you click on this material, then this is the property that available. Okay. This property will be used for the analysis later. Okay. So the next one is what is available for these properties: elastic modulus, Poisson ratio, even the mass density, tensile strength, and if you involve with the thermal analysis, also can. Damping ratio, yield strength, and so on. This is the material that's available. Then you can just click apply. Then you can close it. So I'm not sure you realize it or not. Actually, the color is changed. The color is changed. And just now, the material is not specified. They now turn into AISI 304. If you want to change the material, you can do the same process again and again. This is the example for the material. Okay. After the material is complete, we will do the simulations. Okay. The simulations mean since we got times, then I will explain it more. Okay, for these simulations. Okay. For the simulation, it's simple. This is the tab for the simulations. This is the analysis. It's analysis. If not available in your computer, you just right click and go to the toolbar tabs and select the simulations. Okay. Click on simulations, and we will start with a new study. A new study here. Click on new study. And this is the studies that are available in SolidWorks. Okay? You can use the statics, frequency, topology study, design study, thermal buckling, and so on. Okay? I'll use a static lah. Okay, we are ready to analyze this structure. Okay, this structure. To analyze this structure, actually it's quite simple lah. We just follow the sequence from the top to the bottom, from the top to the bottoms. Okay, the first one is joint group. Okay, it's not necessary for the joint group since you create it using Wellman's. Okay? But the connection is very important here because we want to inform the SolidWorks. This plate is bonded with this structure. So we go to connections and right click and we do some local interactions. Okay, local interactions. And from the manual, we click automatics, and we select the component that we want, this part, and this part, and this part, because the part is touched here. Even for this part, bottom part is not touched, so no need to select this. Select all the necessary part, and you can find local interactions. So there are in total 4 local interactions, which is the first one is between this surface and the inner surface of this one. The second one is where? This here, and so on. Okay, you can see lah. After we set up these interactions, you can click OK for this interaction. If you want to create a selected local interaction, just click. Okay. Then we go to the next step. We call it fixture. Fixture is boundary condition, simple to say. I want to keep the bottom part and the rear part structure stick to the wall. Then I just select the connection and with the fixture. Right click on the fixture, and I want to change it into the fixed geometry, which is we cannot move it. Click on the surface, this surface, and this face. This face is fixed because we stick it on the wall, attach it to the wall. When it's ready, then we can click OK. OK. So we already assigned the interactions between the part and the fixture, which is this face is fixed. Means this face is we cannot move it. Okay. The next one is the force. Okay. For the force, normally we're located at the top of this structure, okay, because we will add in the roof, or maybe you want to consider the extra lot on it, you can simply create your own force. Okay, but how to do it is simple. Okay, for the external lot, just click on the force, and since this is the structure that we select, we can treat it as a beam. Take it as a beam and select this surface. Not surface, but the structure. Okay. Then we want to make sure the directions of the force. You can click spokes to select the directions. You can select the directions at any edge that parallel to y-axis. Okay, because the force is facing down. Okay, I click on this edge like this. Like this. Okay, facing down, and you can change the force. Insert the force. Let's say I want this structure can hold up to 50 kilograms, about 500 Newton lah. 500 Newton. Then you can see the arrow facing downwards means the direction of the force. This is the arrow. Presents the direction of the force. Okay, 50 kilograms. But if you want to force the force, change the directions to the top, then you can reverse the direction. But this is the correct direction. Then you can click OK. Then the next step is we will mesh it. Mesh is in finite elements. We will turn the analysis into n elements. Okay? We just mesh it, right clicks, and we create mesh. Mesh. Let's agree with it. We're okay. Okay. And this is our mesh. Okay. After it's complete, then we can run this study. Run this study. And it depends on the complexity of your study. Okay. The more complex your study, then it will take the longer time for this SolidWorks to solve it for you. Okay. Since this is the simple structure, then it's ready. It's complete. Okay. So as engineer, the first thing that you want to make sure is our design is safe. Okay. Doesn't matter amount or the magnitude of stresses and the properties of the material. We are engineer, we need to focus on the safety. Okay. So for the safe, we can select the result. So for the result of safety. Okay. Just simply right click at the results and you can define the factor of safety. This is very important. We are engineer. Okay. Click on it and we select all body. Of course, we need to determine all the body. Then this let it one is no problem. Let it one. Okay. And we want to create. We will consider the safety. The safety factor is more than 2. Then you can click OK. Okay. So since the value is less than 1, means our structure is failed. So we need to redesign it again. And we change the force from 500 newtons, maybe we change it to 250 newtons. Okay, change, and we rerun the study. We rerun the study again. Okay, now we recheck again the structure, the results. Just double click on the result. Okay, now our safety factor is improved lah. So let's say this 1.2 is still too low, then you can change the material of your structure. For this structure, edit the material, and I select the higher tensile strength. This is 5.1 mega Pascal. Maybe I select this one. Right. Pause. I recalculate again. Then, okay. After I change the material, our safety factor just now is 1.25. Now it's increased up to 3.1. 3.1. Maybe I can increase the force again. 500 Newton. 500 Newton. I can recalculate again. Okay, 1.42. Okay, 500 Newton. You cannot withstand 500 Newton. Maybe you can reduce it 400 Newton. Okay, recalculate. And click adjust. Okay. I think 1.9 should be sufficient for our designs here. Okay, so finally we can agree that our system can withstand 400 Newton, and the shape is look like this, and the profile is 1 inch times 0.5 inch, and the material for this tube is AISI 1045 steel. And this is the conclusion for our analysis. Okay, so instead of sector of safety, we want to visualize how this part deforms. Okay, we can try to focus. Okay. The red color deforms all. You can see this is the scale. Blue color means that for this part there are no deformation at all. But for the red color, it's deformed more. Okay. Even we can animate, you can see animate how the deformations look like. Okay, maybe I can increase the scale. Increase the scale. Okay. It's okay, it's okay. So for this contour of stress of deformations, we can improve our design as well. Okay, because we know that you can see from the stress, where's the stress? This is the stress. Okay. Let me have a look for the strand. Okay. This part will deform more, so we can improve this section. This section, maybe you can add more column at here, additional columns at here to improve our design. This is how we do the analysis. Okay. For your information, the design's work is iterate from beginnings and keep iterating until it's success. This is the way how we get the analysis. Okay. But after everything is complete, we can turn our results into a report. Just click at this report. Click at this into a report. Okay, and even you can insert your names, designer. It is my names. Yeah. Company can put any that you want, any details available here, then can publish it into Microsoft Word. Okay. It's easy lah for us to do a report on our design. Okay. Let's take time to generate our report. Okay. But after we complete our report, then maybe you need to edit something lah, because maybe the arrangement is different lah. So this is the product. This is should be the company name lah at the top here. Okay, this is the simulations of part one. This is the part one is the name of my product. I haven't given it a name yet. Really, I need to save it and give it name lah. Okay. With that, the designer and a type of study, and then complete with the table of content. Okay. And this is how we allocate the constraints, and it's quite detailed for the report. Okay, for the report is quite detailed. Okay. Even the value for the force, and the resultant force that react. Okay. And the beam force as well, and the results for each study that we done just now. So like this. It's the result that available. Okay, this is for the report. Okay. Then the next one is, okay, we still got time, so I will go to the next one here. We will visualize it, or we will visualize it lah. Render our products here. Okay, for render it, the model is our products, and I will visualize it. How to visualize it? Go to render tools. Render tools, and just click at final render. Final render, and you can save the file in JPEG format or any format, any photo format. Final render, take time, and this also depends to the performance of the computer lah, especially the graphic card. Take time to render. Okay. Okay. For the render, actually you can add in the shadows or the background or anything like that. It's not nice, this one. Okay, let's say we are finished, then you can save the image. You can save the image. And finally, we have products. Okay. So the next one is the drawings. The drawings. Okay. Since we got time, I'll show you how to convert our products into drawings. Okay. The first step is I need to save Save it. Save file. So you put it at desktop. Desktop. Right. Example for yes. Okay. Okay. So, okay. So I open a new file, call it drawings. Drawing file. The drawing file, I will turn our model into piece of paper. Okay. So I can select the block title that available here. Let's say I use this NT landscapes format. NT landscape format. Okay. Okay. This is the format that available. Okay. And then insert the part here. The part, this is the part. Okay. And we put it in isometric view like this. Too small, then I can change, scale it up. Okay. Scale it up 1 to 20 or whatever you want. 1 to 12. Control the scale that you want. 1 to 4. It's too big. 1 to 8 should be nice like this. Okay, like this. Okay. After it's complete, you can move the, you can arrange the part wherever you want. Okay, arrange your part wherever you want. And then this drawing, not so important. The most important is the table. Get bill of material for this part. Okay. Click on it. Okay. Okay. So this is available. Okay. And maybe this one, can delete it. Part number. Can remove this part number to the unit of measurements. Okay, so you can change it lah. Maybe cut these properties. The length, get the length. That is the length. You can provide the length for each material. Arrange it. Okay, maybe. Okay. That one, I think something wrong with my. I cannot drag it. I can. Now can. Okay. Drag it to the side, and even I can auto balloons on this part lah. Item number, length, wait I need to change something here. Let me call how to. We will redo it again lah. We do it to delete the table. Just simply delete it. So bill of material, this drawing, only. Okay. We redo it again. Only one. Cannot. It's too little. Okay. This is the best best table you can provide lah for this cut list. Okay, so maybe you can change this one to the length, to the units, these properties, and the length. Okay, so the information here is quite important lah, quite important to so that when you give these drawings to the to our warehouse to do it in-house, then they will use this measurement to provide the raw material. Okay, this is the bill of material. Second drawing is the dimension lah, the dimensions. Okay. Object drawings. View it from the side. From the side like this. Okay, from the side like this. Okay. And then you can change the scale. 1 to 8 now is nice. Like this. Okay, then you can insert the dimension. Okay. Okay. So maybe for these dimensions, this one is equal to this one. Okay. You need to rearrange the dimensions properly. Okay. You need to rearrange the dimensions properly, proper manner. Or if you don't want all in one view, you can project it to another view. Project it to this side, like this. Okay, this is the side. Then you can move the dimensions from here to here. Okay. Here, and you can delete this dimension. Okay. This dimension also, you can move it to here. Yeah. Okay, and you can delete these dimensions and rearrange the dimensions properly like this. Rearrange the dimension like this. This one, you can move it to here as well. You can delete these dimensions. Okay. This one also. This direction. Okay. 25. Move it to here. Okay, arrange it like this. And we remove the unnecessary dimensions. When everything is ready, then you can give a name on the view. For example, this is maybe the side view, so that we know the sequence of the view. So rearrange the dimension like this. Okay, maybe you can change these dimensions like this. It's better. This one also, change it. Okay. This. Okay. 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 But if this view is too crowded, we can use the additional detail view and maybe if some things that cannot see inside, then we can change it to another display style. Maybe this hidden line visible. But for this structure, since it's very big, I think for this hidden line remove is sufficient for our design. Okay. This one. Just remove this one. Okay. This is for our drawing. Second drawing. So the measurements is here, and overall view of the products is here. They will cut the length according to this here, and they will fabricate these frames according to this design here. Design here. Okay. Then you can change in the information here. Edit format with all the necessary name, title, material, and the person who draw, person who approve, approve. And this is the manufacturer. Even the quality will need to fill up this information here. Okay, this is all about the drawings over here. Very much. Okay. So any format that you want, maybe save it in PDF format. Okay. Save it in PDF format. Okay, let's see the outcome. Format on the desktop. Okay, this is the outcome of our drawings. Okay, this is what you should know because you are the future engineer. Okay, I think drawing is very important. Okay, we cannot disagree. In the young engineer nowadays, it's quite weak. They not even can read the drawings properly. So I hope this brief explanation about the drawings might give you an idea how to develop the drawings from the product that you create. So next is the weight estimations, the max estimations. Okay, so during attached to the company during my consultancy works. Okay, some of the company required the weight estimations of the material, because from this weight estimation they can estimate the cost of the projects. Okay, the cost of the project normally is the weight of the metal. Okay, they will multiply the weight with some weightage to get the cost estimations of the project. Okay, so to get these weight estimations, since it's SolidWorks, that we sketch this down. Okay, you already get what the shapes, and insert the material, or we can get the wet estimation easily. Very easy to get the wet estimation. Okay. Then we'll go to evaluate here and select the best property. So overall weight is 3 kilograms, 3.6 kilogram for this product. Okay. Of course, this product is not cannot be standard single piece. Yes. Somebody any questions? No. Okay. So we can multiple the products into a set. Okay. You will see what will happen because this is the structure of the awning. Structure of awnings cannot exist in one piece like this. You must have a pair. Pair is more than 1, 2, maybe let's say it's 3 3. Okay. To multiple the number of this structure, and maybe use the mirror commands and the linear pattern command to multiple the number of this part. Okay. The most simple way is to mirror it because the directions of the support here is facing inside. Mirror, you need to insert the plan mirror. Let's say the left side and the right side of this structure separated at 2 meter length, 1.5 meter length, 1 meter. Then the plans that you need to refer to is half of it. So you try to insert the first reference geometry plan, and we can set this plan of it. Let's say it's 500. Okay, we will mirror this part to this side, which is this plan number 2, the face of mirror. Mirror under the feature step. The feature step. And the face of mirror is clearly stated here. You just need to select this plan. Then the bodies to mirror, click this. Or the best way is you select all of it. Select all of it like this. Include this one. Okay. This one. Okay. Then so like this. Now we have a pair of the structure. Pair of structure. And then if this pair number 2 is annoying, I think. So from now we can have the additional part here. Of course, when the additional part here, then the mass is different, which is double up from 3.6 now turned into 7.3 kilograms. Okay. Really, our analysis just now is quite good because the 400 newtons we only consider for one side, but if we consider for 2 sides, maybe the load will be divided. Maybe it's not divided equally. At least some of the force will transfer to this side like this. I think that's all for my introduction I call it introductions. Okay, I will provide my contact for those who are interested in this software, then you can contact me. Yeah. Okay, let's see. That's all from me. Maybe you can open for Q&A questions.
Thank you, Professor Sia, for such great input. Now, as we proceed with a Q&A session, I would like to welcome all participants to provide your question in the chat box, or you may unmute yourself to ask questions. Feel free to ask IR Dr. Sia Kiong some question related to SolidWorks.
You can ask any question lah. Even the question is simple.
Yeah. So from our side, we have a few questions. So the first question is, hi Professor, I'm from the Civil Faculty. Can Professor explain the major difference between AutoCAD and SolidWorks?
All right, it's a quite common questions lah for me. Okay, because since I know how to use AutoCAD and how to use both software, okay, but the AutoCAD is widely used in our country. Okay? You go to any company in civil works, they will use this AutoCAD. The reason is simple. The reason is the cost. Okay? The cost. It's very cheap. You can get it even less than. Okay. Wait, I will let you answer this one, okay? So SolidWorks consider low end modeling software, but it's very useful because to use the AutoCAD, to use AutoCAD, you need to know the how to read the drawings, okay? How to read the drawings, okay? Because it's only provide the two-dimensional view, okay? Three-dimensional can, but quite difficult to produce using AutoCAD. Okay? But for the SolidWorks, it's more on product design. Okay, for product design, even involving the analysis and the mold design and so on. Okay.
Thank you, Doctor. The next question is there any limitation for SolidWorks?
Any what?
Is there any limitation?
Limitation?
For SolidWorks? Yeah.
Okay. So for the SolidWorks itself, actually they consider as the medium software. The highest level of SolidWorks in this family is CATIA. CATIA now uses by Proton, Proton industry. They use CATIA. The limitation is here, yes. Maybe the number of elements when you do the analysis. Okay? Number of elements. And for the latest versions of SolidWorks, we need to use the higher operating system. Like for my case, 2021, I need to use at least Windows 10. But for the versions 2022, I heard we need to use Windows 11. It's quite hard when you want to change the operating system in our computer. Okay. That's all.
In the chat box, we have a few questions.
Okay.
So our first question is related is the same lah. So they ask, may I know how long will we take to fully master this software?
Okay. My experience, my observations. It depends to your interest. Okay? Some of the students, they can master it within a month. Okay? Some of it maybe take a year. It's very subjective to answer this. But some of them, they're willing to learn from YouTube, because we know YouTube is our teacher. I cannot disagree with this. Okay? Sometimes after we learn something and we want to know more, we will refer YouTube. Anything is YouTube. Okay? But I very agree, because YouTube we can learn a lot of things. Okay? But if possible, maybe you can visit the Solidworks website and they give you the thing that you need to know. Okay? And then from there, you can learn from any formal or informal method lah. Informal means you can attend the class, but informal you can learn it yourself from the YouTube lah. Okay, something like that. Okay. The answer is very subjective. If you are good, then you can learn it very fast. My student, within a month, can master everything.
Okay. So the next question is there any application in SolidWorks that check environmental impact or sustainability of part created in SolidWorks?
Yes. This City New Africa is the person who asked these questions. I think she know how to use SolidWorks lah. The answer is yes. Okay. Brief about this sustainable impact is we know sustainable come from three main pillars. The first one is the environment, socials, and the economics. We need to balance up these three pillars. Okay. So for SolidWorks, for the environment, I think they will consider the carbon footprints and things like that lah. And for the economics, maybe they will consider the locations. For example, the database come from the main region lah. If Asia, they will consider the Asia. If Europe, they consider Europe. How they transport the thing is different. SolidWorks can do that. Okay, SolidWorks can do that.
Okay, our next question is, Professor, I am really interested with SolidWorks. How to contact you if I need some help from you regarding SolidWorks? And what are the difference between SolidWorks, Abacus, and analysis, finite element analysis?
Okay, so solver, the problem is solver. Okay, so for the Abacus and ANSYS, okay, it's very strong in analysis. There are the limitation is very high. SolidWorks, there are limitations quite low, because for the SolidWorks, the main purpose is to produce the geometries that we want. For the analysis, maybe you can create a part from SolidWorks, and then you can set the file into STL formats or any formats that can be used in Abacus and ANSYS. All simple to say, you can use more than one software, but for SolidWorks, to create any geometry that you want, is very recommended, highly recommended. But for the analysis, I still ask you to use ANSYS. ANSYS very high, it's very good software, ANSYS, but very expensive. Unless you can get pirate. But this sort recommend for you to get the pirate.
Okay, for the next question is, it is possible to create and assemble with two different tensile strength?
Yes. Okay. So what this Roha Datu Aisha means, there are two different material. Okay, two different material in one structure or one assembly? The answer is yes, it's possible. Good question, Roha Datu.
Alright, so the next question is, during the earlier presentation, Professor got mentioned that UTH aim to provide certified Solidworks EDU, right? Can I know when do the registration open and when I can register for that?
Okay, for this program actually, this is I just completed our second batch of the students. Okay, it's open to FTK and KMP students currently, but since they already got basics in SolidWorks, okay, they just come and we provide the mock test and maybe the environment, how the exams runs, okay, with a very minimum explanation about the skill of SolidWorks lah. Okay. We got two. Let me share something here. This is our previous. Let me share first. Okay, this is our previous program lah. Yeah, this is our previous. Also, there are two packages that are available. Okay, but for the next batch of students, we will inform it. Maybe next month we will try to advertise it. Maybe next month. Okay. So for your information lah, for previous batch. Okay, wait. Let me show you something. We out of 50 students, I think 49 students is pass the exam lah. Pass the exam. 49 students pass the exam. Okay. Okay. So for the SolidWorks itself, I'm not the seller for the SolidWorks. It divided into three levels. Okay, three levels. The first level is the associate level. The second level is even the electrical also got. The second level is for the professionals, and the third level is for the expert. Okay, I try to get for the expert level soon. Okay. For the associate level, currently most of the students from mechanical KMP who take this program, they already at least associate level. But after they successfully join the associate level, then when we open again, they will join it in professional level within a few months. Okay? Currently for the students, I think about 7 to 10 students of KMP students already professional level. Quite impressive for this achievement. Okay.
Alright, for the next question is, how do we copy a complete assembly to one folder along with the drawings and all reference parts in color?
Pack and go. You means try to combine all the file in one folder.
Yeah.
Yes. Okay. You can use the pack and go. Okay. How to use pack and go? Let me show you. Can I share my screen? Pack and go is here. Okay. File.
Doctor, you're not sharing the screen.
Okay, sorry. I shall share first. Syahrul Nizam. Okay, here. For this file, for example, just go to File and Pack and Go. Pack and Go, you can save all the components, include the simulation results. Okay, and you can choose any folder that you want to save. Okay, am I answering your questions?
Yes, it works. So, for our last questions, Doctor, where can I register for CWSP certification and how much does it cost?
Okay, if you sit the exam by yourself outside, okay, it costs you about $99 US dollar if outside lah. But if you join in our programs, if you only sit for the exam, it costs you 120 ringgit. But if you want to attend the course, complete course, it's take you 600 ringgit Malaysia. Okay, 600. So I recommend you to learn by yourself first. After you improve your skill, then you can join the cheaper versions, 120 ringgit. Because don't worry, because even it's 120 ringgit, you can sit for the exam lah. Normally for the retest, we will give opportunity for you to retest one time, free retest one time lah. Okay.
So, there's all the questions from the participants. So, thank you very much for all of the questions. I hope that the answer that IR Dr. Sia provided will be useful for everyone.
Okay.
So, this time, thank you, Doctor.
Okay. Thank you very much for the invitation.
Yes.
Okay. See you
So,
again.
once again, we would like to thank Dr. IR Sia Kiong for sharing his knowledge on SolidWorks. It is a pleasure to have you here with us today. We also hope that our participants found this workshop very informative and worthwhile. Now, we have almost come to an end for our event today. I would like to invite all of the participants to join together to turn on your camera for a photo session. Multimedia team, please help us to conduct the photo session.
Hello everyone. Please switch on your camera. Alright, I'll be taking the photos in 3, 2, 1. Alright, another one. Three, two, one. Okay, thank you.
Alright, thank you, multimedia team. So,
Okay. Thank you very much. See you again.
yeah, thank you, Doctor. Thank you very much. So, as a reminder to the participant, please fill up the attendance and feedback form that is provided in the chat box to get the SNAP and e-certificate. Our attendance form will be closed at 1 p.m. today. Participants are informed that any requests received after 1 p.m. will not be processed in order to facilitate verification. IEMSS-UTHM apologize for any inconvenience caused. Alright. Before we end today's session, please follow us on Facebook, Instagram, Telegram, and LinkedIn to keep up to date with the latest announcements and upcoming events. Participants may leave the meeting now once done filling the form. See you at the upcoming event. Thank you and goodbye. Bye.